So today we're going to talk about troubleshooting and maintenance of the XIV R2 storage system. We're going to look at how to check the status through GUI and XCLI of each of the components. The visual indicators on the components themselves look a little more detail about events, alerting events, internal and external events. XCLI component list we'll go into a little more detail, and that's going to be your best friend in determining what's wrong with the system. And we're going to mention several times until you're tired of hearing it about how you need to wait for redundancy before you do any maintenance on the system. We're also going to talk about how this machine, you want to do one maintenance action at a time. Make sure that the previous maintenance action completed before starting the next maintenance action. You don't want to do a component test on two components at the same time. Wait for one to finish before you do the next one. An example would be a switch. If a component test results in the reboot of a switch and you do both switches at the same time, guess what? You're out to lunch. We're going to look at parts replacements, the difference between a failed and phased out component, the physical replacement, how to test, how to phase components back in. We're going to talk about code updates, data collection, and the maintenance module.
One thing we mentioned on the first day was that phase out of a module can take up to 6 hours. Is that a good experience?
That's the phase out of a module can take up to 6 hours if it's a fully populated system, and that's another thing we'll look at. There was a lot of questions on the way the data is distributed throughout the system.
The reason I asked the question, I mean particularly in terms of okay, a module died, rebooted, something bad happened to it.
Yes.
So it's now being phased out, and maybe 4 hours later, phase out finishes. I don't know. So then the SSR doesn't have any parts, so he does a test on it, and the test passes, so he phases it in, and that takes what, 4 hours?
Correct.
And then 20 minutes later it reboots, so it phases out, which takes another 4 hours.
Well, that's why you should never do a dummy replace on a component. You always replace it. You don't, if you test a component that has failed without replacing it, like you said, it may come back and function, but then it has the probability of dying once again. So anything like a module that fails, you definitely want to make sure you replace it and not just do a dummy replace and bring it back into the system. When a module fails, the phase out, it's not really phasing out. At that point, it fails hard, and it's marked as red.
So at that point, you do not have second copies of any data that's on any of those copies.
Correct.
So it's regenerating those copies, recreating.
No. Well, what happens during a failure is you go into a rebuild process, okay? And what happens is the secondaries doesn't matter. The secondaries that were on that module doesn't matter because the primary is somewhere else on another module, but without a secondary. So what happens is it rebuilds. The module that owns the primary knows that his secondary copy is gone, and so he'll send a copy to another module, a secondary copy to another module. Now the primaries that were on the failed module, the secondary module, the secondary copy resides on another module, and so that module says, hey, my primary just disappeared, I'm going to send a copy to somewhere else. I become the primary, and I send a secondary to some other module. And so this is the rebuild process. And redistribution is different, and that's when you phase something out, it's proactive, and what happens is that module still participates. It becomes read-only, so its primary and secondary copies are still active. And what it does is it redistributes that data that he has ownership of. He redistributes it to other modules and creates a third copy until it's completely done, and then he goes away and he dies. Right. Okay, so a failure is treated differently than a phase out. During a failure, you have a rebuild process, which the secondary, the primaries that had a secondary on the failed module will generate a a secondary and send it to another module. And the secondaries that just lost their primary will become the primary and send the secondary to another module.
When a phase out is a redistribute,
Right.
where so what I'm saying, the module dies, so a rebuild occurs.
Mm-hmm.
The SSR then goes, well, I don't have any spare parts, but I'm a clever man. I run the test and I reckon there's nothing wrong with it, so I'm going to put it back in.
Yep.
I redistribute again, then the module dies again, so a rebuild occurs.
Yep.
This is what I was just thinking. How many hours is this guy going to burn before he puts his hand up and says,
Yeah, I need a part. Well, hopefully none, because you know, if they do that, they should be slapped on the hand and they won't do it again, right? They should always replace a module if it fails. Don't try. And we're going to get into this. You don't want to be a cowboy on this machine. You know, don't be a hero. That's one of my slides. Don't be a hero, and try to fix this without doing the proper procedures. You know, the question was though, does a redistribute? Is it redistribute quicker than a rebuild? I would say yes, because the module that you're phasing out is participating in the redistribute. But when a module fails, you no longer have that additional processor or disks participating in the rebuild process.
So isn't one of the major reasons behind that there's no single point of failure then when you do a phase out, right?
Correct.
That's
Yeah, the point of the redistribution on a phase out is you never lose redundancy during that process. On the failure and during the rebuild process, you're actually exposed to a second failure at that point. You're not redundant, and you have the potential of another failure impacting the system.
So during the phase in, you're not at that same exposure.
Correct.
Right.
Yeah, phase in, it's simply, you know, during a phase in on a new module, what happens is the system says, hey, I got more storage. And everybody, all the other modules, take 1/15 of their data and try to put it on that new module. So they equalize.
third
Their,
copy.
right, until, yeah, before they remove their original copy.
I'm probably going to anticipate another question, but okay, so the module died, and at this point a rebuild is occurring, and the rebuild might take up to 6 hours.
Correct.
And I've got the module sitting there on the desk, brand new one. I don't do anything until the rebuild.
That's correct. Yeah, good point. Even though you have a module sitting there and that module's dead and it's not participating in the rebuild, you don't want to approach the machine until that rebuild is complete. Because if you go into the back of the machine and inadvertently unplug the wrong module, you're now dead. You're worse than dead. You lose all your data. Yeah. So that's why. What's that? No, I mean, you can't enforce by code.
The SSR is thinking, hey, I'll save myself some time. I know this module's dead, so why don't I wait while the rebuild is occurring?
Right.
Why don't I swap out this module?
Correct. Yeah, you do not want to touch the machine when the rebuild process is going. No, the service GUI cannot enforce somebody walking up to the back of the machine and pulling the cables. Okay, so. No, okay. All right, we got side conversations going on here. When you see a failed module, there's nothing you start in the GUI to say to do a replacement. You simply replace the component, and then once the physical replacement is done, then you go to the service GUI and do the test. There's no
guided maintenance.
There's no guided maintenance. So excuse me?
You have guided maintenance?
Who let the R1 guy in the room? Yeah. Yeah, in R1 it is different. I mean, if a failed module, if you know the module's failed, what's to keep you from replacing it before the rebuild's complete? Exactly. Okay.
While the rebuild's occurring, I can use an XCLI command to get the percentage.
Yes. Yeah, during a,
Really, the customer should be saying is, hey, the CE should say, hey, Mr. Customer, keep hit the up arrow, hit enter. When it gets 100%, or when it gets to 90%, ring me. I'll head back in.
Right, yeah, during the rebuild, you can do monitor_redist, and it'll show you the percentage complete of the rebuild that's occurring. Well, already, okay, let's take a logical step through on a failure. The component fails, the machine or the customer is going to call home, call service, but already it's starting the rebuild process. So how quick are you going to respond to the call, analyze it, dispatch a CE, get a part on site? I mean, you're looking at several hours there anyway. Yeah. I'm sorry? Yes. Well, it'll say rebuilding down in the lower right-hand corner. You have that meter. Correct. Yeah, it'll say not redundant. Once the rebuild is complete. Yes. Yeah, once the rebuild is complete, it'll say fully redundant, even though you have a failed component. Okay. Okay, so we'll get into more of this, and it's lively discussion, but I think you'll see how it all fits together. Except for the R1 folks, I don't think they'll ever get this R2 stuff. And, okay, code updates, data collection, and the maintenance module. Back to the slides for you guys. Sorry for the sidebars. So, rule number 1. Always wait for the system to be fully redundant before performing maintenance. Okay, we're going to say this over and over and over. So what's rule number 1? Keep smiling. You know, rule number 2, we already talked about this. Don't be a hero. F. Scott Fitzgerald once said, "Show me a hero and I'll write you a tragedy." This box is a tragedy if you try to be a hero. So, like we said, you want to wait. Don't go being a cowboy on this box. We all are engineers, and we all think we know the best action to take. But again, not knowing this box and the fact that it's brand new with no field runtime at customer sites, we want to be extremely careful on what we do. We want to make sure that we clear any action we do with development before proceeding, because we just don't have experience on it, and we don't know what the ramifications are of phasing in a module before it's done rebuilding or that sort of thing. So, you know, if you think there's any sort of question or you get off script on something doesn't look right, you're following a procedure, just immediately stop. Don't try to fix it yourselves until we get more experience on the box. Just stop, get help, and talk to development or, you know, your next level of support. How easy will it be to get development engaged? It's going to be extremely easy. What they're going to have is they're calling it the extended XEST, or extended services team, basic XIV extended services team. A member from the development team will be in each geo, and they'll be your first line of contact. Well, actually, for GA, your first line of contact is going to be technical, or PFE, your technical lead in PFE. And if the technical lead in PFE cannot fix the problem or guide you on what to do, they're going to say you need to contact development and initiate that process. We'll help. The PFE is going to help you get in contact with that person and stay with you until they're contacted. But the developer is going to want to talk to the person on site directly to get firsthand information about what's going on. So PFE may stay in the loop to learn, you know, to help out, to provide guidance or whatever, but the goal is to get the field person talking directly to the developer so we have firsthand knowledge of what's going on. We don't want to be playing middleman, okay? Rule number 3, don't be Dr. Frankenstein. Don't go swapping parts in this box. You don't want to create a monster, okay? You may think, oh, this is working fine. I have a failed module, I'm just going to swap this part in. I'm too lazy to put in a whole thing. I just want to put in a new FSP instead of replacing the whole module. You know, it may sound like a good idea when you're in the field and it's 2 a.m. and you want to go home, but okay, you may think it's a good idea, but refrain from swapping parts on any of these machines. We talked about, or Ian pointed out during his overview, some certain no-nos that you don't want to do. Compact flash has information that you don't want to. You definitely don't want to swap compact flashes between modules. You don't want to swap ports on a switch. You don't want to swap. You don't want to swap USB to serial cables. You say, oh, this one might not be working. Actually, the USB to serial on the UPSs are different than the USB to serial going to the other modules. So you plug in the wrong USB to serial cable on a UPS, and that UPS is going down. It goes down hard. I found that out because I was playing Dr. Frankenstein. I got my hand slapped too. So now we're going to look at checking the status LEDs. There's some visual indicators on each module has front and back LEDs. We'll look at the switch LEDs and the LEDs on the UPSs as well. On the front of the modules, you'll see right next to it's the left-hand side of the module. There's a little op panel, if you will, that has the power button and an ID button. It also has an attention LED on it as well.
And that adapter allows you to hook your iPod up to it.
Yeah. This is a mini USB to regular USB adapter. This was used as part of manufacturing to initially load the machine with code. It may be required. It's shipped. There's a few of them shipped with each machine in a little baggie. It may be required if we have to offload data on a module or if we need to update firmware on that module. On the back of the modules, you have LEDs on the power supply units. Solid green LED indicates that the machine is on and it's receiving AC power. A flashing LED indicates that the system is powered off, but it's still receiving AC power. And if it turns yellow, it indicates that that power supply has failed. There are also some motherboard indicators on the back of the unit, and we'll take a look at what some of those mean. But for most of these are mostly post codes, power on self-test, and the sequence in which they flash would give you an idea on what's going on. So the server board contains diagnostic LEDs to help identify failed and failing components. It also helps you to identify the failed server among several servers. So the hope is, I don't think this is quite working yet, but they're going to turn on that bright blue LED when system has failed if they can. Except for the ID LED, the status LED, and the 5-volt standby LEDs, the LEDs turn amber only if a failure occurs. So here's a picture of the motherboard in the actual modules, and the LEDs that we're concerned with are A through F, are the ones that you can see through the back of the enclosure. And there's a website you could go to for this Intel motherboard, and it basically tells you what position, like this is bit 3 LED, contains a post code, least significant bit LED, another post. Now the switches, their LEDs are located on the back of the switch, facing the back of the machine in the upper right-hand corner. They indicate the status of links, power supplies, fans, diagnostics, and the state of the stack. Green equals good, red equals bad. That's good. You probably have noticed that there's power and an RPS LED. The RPS is lit when it's receiving power from the RPS system, and the power LED is lit when it has AC. So during our maintenance lab today, what you're going to do is pull power from the AC power from a switch and take a look at the LEDs, and plug the AC power back in and pull the RPS cable and see what that light looks like. Let me give you a word of caution. If you pull the RPS power, there's a little tab on the top of the connector. You want to push the tab down before you pull the connector out. Anthony learned that, right? That's right. So yeah, make sure you plug it back in. So here we see a close-up view of those LEDs. And what you're interested in are the diag, fan, temperature, RPS, and power. The UPSs. UPS LED indicators. On the left side of the UPS, you actually have a load indication on how much power is being drawn from that UPS. And here's a chart showing the percentage. On the panel itself, there's only the LEDs. They don't give you the percentages, but here you go there. The right side LED indicates the percentage of battery charge. Again, we talked about there's a threshold, and I think you need at least 3 LEDs lit for the system to IML. It needs to be above 48%. There's also some middle indicators, and they have symbols that we're going to look at on the next page. This is the button that you never want to push to power the machine off, right? So the upper LED with this symbol indicates that the UPS is drawing utility power from the customer, or getting AC power to the UPS. Then we have an on battery indicator, a bypass. Bypass LED illuminates indicating that UPS is in bypass mode. Utility power is sent directly to the connected equipment during bypass operation. So that means it won't supply power from the battery. It'll supply direct power from the utility power. So that's why we want to make sure the switch on the back during installation is set to online and not to bypass. There's a fault indicator, overload, and an indicator if a battery is supposed to be replaced. Now we've seen some situations in the lab where the UPS is complaining and it has a replaced battery light on. Now, the self-test of the UPS will fail. If you do a UPS list on a CLI command, it'll actually tell you when if it's passed or failed the last self-test. Now, what we've seen is the battery charge level gets out of whack in the UPS. And what we've done is removed AC power from that UPS that's complaining and let the battery drain until the UPS powers off. And then reapply the utility power and let the batteries fully charge, and this error goes away. So this is something we're seeing in the field right now. I don't know if they'll be able to fix that with a firmware upgrade or not. Any questions on the LED indicators? Yes.
Not the LEDs. We had the problem yesterday. We powered off the machine, we powered off the UPS, and the fan still was running, even if we disconnected the input power.
Okay.
Does that mean that the battery will be...
Yes, the question was they powered the machine down, disconnected the AC input, and the fans on the UPSs were still running. It will drain the battery. That's one reason why they ship the batteries unplugged when they're initially shipped. So if you're going to shut the machine down and it's going to sit for a long period of time, you probably want to disconnect one of those battery connectors to prevent the battery from discharging.
But if the customer powers the machine off for whatever reason, and then after some time he powers on, and then he has to wait until the battery is...
Correct. Yeah, he'll have to wait until the battery. So they should be warned that if they power down the machine for any length of time, they should remove a battery connector to prevent the battery from draining. That's why we're shipping them with that connector unplugged. Yes.
Suppose you hit the power off button on the UPS, it still runs the fan?
I'm not sure. Did you try that?
Yes, we did, because our UPS took the power off.
So did the fan stop when you
No.
powered it off? It still continued to run? Okay, but,
UPS behave the same. The ones that power off automatically, the ones that didn't.
okay.
But even if you push the off button, it wouldn't manually turn it on?
The only thing that stopped that fan from spinning was pulling the battery back.
Okay.
We turned off the breakers at the back, we pulled the AC in, neither of those things affected.
Yeah, the breakers in the back are only affect the output power. They don't affect anything going on the UPS. So that's something you can try in the labs today. Is you know, see what you can do to power the machine down and see what you can do to get that fan from
What we
running.
noticed is when you remove the battery plug, replug it, and the fan did not start.
Right, until you plug the AC power back in. That's when the fan will start up again.
I tested the fan with my ID badge. I can
They
tell
stick
you,
a
Yeah.
it was spinning.
Why don't we take a break here before we go into events? And so let's take a 15-minute break and come back.